Here's a video about one version of this problem from the online homework. And this is the way a lot of lottery problems work. The premise here is that a student writes down four numbers from a set of options. Here our options are 1 through 14. And then the teacher, or the person conducting the lottery, picks 8 numbers from the same set. And the student wins. Excuse me. If the student wins, if all of their 8 numbers are among the all of their 4 numbers are among the 8 numbers the teacher picks. So the reason this can seem confusing is because it seems like there's 2 random things happening. There's the number the student writes down, and then there's the number that the teacher selects. So if we think about the order this happens, the student writes down their number first, and then the teacher selects. It makes sense that it really doesn't matter what 4 numbers the student uses. It makes sense that no matter what the student writes down, they have the same probability of winning when the teacher actually makes the selection. So because of that, let's just say that the student writes down the numbers 1, 2, 3, 4. Okay. So those will be the 4 numbers that the student picks. One way to think about it is that part's not really random, right? That part is the student attaching themselves to these 4 numbers. The random part is what the teacher does. So the random experiment, that's what we called that in our statistics language. So we have a chance experiment. The random experiment is the teacher choosing 8 numbers from 1 to 14. And so we know how many outcomes there are for that. So there are 14, choose 8 possible outcomes. The event, the thing we're interested in happening, is the student winning. So the event is the set of all outcomes where the student wins. So remember, the thing the teacher is picking is 8 numbers. We want to know which of those 8 element subsets of 1 to 14 has the student winning. So the student wins if the outcome looks like this. If the outcome looks like 1, 2, 3, 4, followed by, well, let me write down a different line. Looks like 1, 2, 3, 4, W, X, Y, Z. So remember, these are what the outcomes look like. They're 8 element subsets. The student wins if numbers 1, 2, 3, and 4 are among the 8 numbers. So any 8 element subset that looks like this, 1, 2, 3, 4, followed by 4 other numbers, is going to mean that the student won. Anything that doesn't use 1, 2, 3, 4, the student doesn't win. So here, it could look like this for any W, X, Y, Z that comes from the remaining numbers. So the W, X, Y, Z would have to come from the set 5, 6 through 14. And so the number of winning outcomes then, the number of outcomes for which the student wins, are just the number of ways to pick 4 elements from the numbers 5 through 14. There are 10 numbers in 5 through 14, so there are 10, choose 4 of these. 10, choose 4 because we're picking the remaining 4 numbers from the other 10 numbers available. So of the 14, choose 8 possible outcomes total, 10, choose 4 of them would be winners for the specific lottery ticket 1, 2, 3, 4. And since we believe that doesn't matter which ticket the student plays, the same argument would give us the same probability. So the probability of winning is going to be total number of outcomes on the bottom. It's 14 choose 8. The number of those in which the student wins is 10 choose 4. So that ratio, 10 choose 4 divided by 14 choose 8, is going to be the probability that a particular student wins a prize.